Welcome to HP Tuners Subaru Training Part 8. In this training tutorial, we're going to be focusing on the differences between mass airflow style tuning and speed density volumetric efficiency style tuning. We're going to learn about the advantages and disadvantages and just understanding how these two different airflow calculation methods can be implemented within our Subaru ECU operation. We're going to find that the speed density is going to be something that we can add on as a HP Tuners custom feature patch that's not otherwise there in the Subaru logic. We're going to cover a lot here in this tutorial. Let's jump in so we can check out the differences between working with our mass airflow and speed density.
Okay, so let's get started. We're going to be taking a look at our mass airflow and speed density type of operation with our Subaru ECUs. We're going to find that factory Subaru ECUs are going to be mass airflow based. They do have a MAP sensor that's used for boost control, among many other type of calculations in the background. With HP Tuners, we can run an enhanced patch to convert over to speed density, where we ignore the mass airflow sensor and run purely off the MAP sensor and the estimation of airflow. We're going to break down in this tutorial, understanding how the mass airflow modeling strategy works, and then take a look at our speed density operation, understanding how that's going to work and how it plays a role in calculating both our air and fuel modeling. This is just going to be understanding, again, the concepts of what's going on here. We're going to move into dedicated tutorials, taking a look at doing the actual tuning. But I want to go and dig into the background so you understand exactly how things work within the ECU. It's always good to understand these fundamental concepts so we're not just going in and arbitrarily putting random numbers into our tables. We want to know what they mean, what they represent, so that we have a more educated way we can look at and analyze our data and making our changes. So the first thing I want to talk about here is the mass airflow operation mode. This is how Subaru's intended and designed the ECU to work. We have a mass airflow calibration strategy open right now. This is going to be here if we jump up into engine and I go in here to airflow. We find in this general tab, we have our MAF calibration table. This is going to be where we have a correlation between a voltage and an actual airflow registration, and the ECU is going to use that then for all of its calculations. Let's jump in here and take a look. We're going to go into our cal table right here, and we're going to take a look. We see on the left side of our table, this is going to be mass airflow in volts. So we'll find the factory mass airflow sensor is a 0 to 5 volt output sensor. 0 volt is the lowest that it reads, and 5 volt up top here is the highest that it reads. Now, an associated voltage, let's just say here arbitrarily, let's pick a random value here, at 1.25 volts. It's going to tell the ECU, if it's sending that signal back in as the airflow is passing over the sensor, that it's going to be registering 3.49 grams per second. Now this grams per second value here is going to be used for a whole lot of different calculations within the ECU. The first thing it's going to do is take a look at our fuel and airflow modeling relationship and determine what type of fuel delivery that we need to go in and apply to the engine. Now, the underlying equation that we have to deal with is going to be fuel mass is equal to air mass divided by target air fuel. So taking a look at this, depending on what the voltage is showing that's coming out of the actual mass airflow sensor, again, as the airflow is passing over it or through it, we'll find that it's going to have an associated amount of flow. So in this case, 6.3 grams per second. That's going to be our air mass. Now we need to specify what we want to run for a target air fuel, and that's going to be found in the target air fuel table. So let's close this out real quick here. If we jump into fuel, into open loop, into our open loop base, taking a look at our base fueling here, we have our values. Just take a look at our table here. We're going to find that this is based on engine speed and based on engine load in grams per rev. We're going to get to that in 1 second, but this is going to be specifying our target air fuel. So if we know what our air mass is coming from our mass airflow sensor, and then we know what our target air fuel is, we can determine what a fuel mass should be. Now, fuel mass is going to be what we want to actually deliver to the engine based on both knowing air mass and target air fuel. We convert the fuel mass into an injector pulse width, knowing specific characteristics to the injector, so the injector flow and how the injectors respond. We're going to have a dedicated video taking a look at our injector data coming up here in the training course. I don't want to get bogged down in this tutorial talking about any kind of injector data.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.